back. In this video, we look at expanding more complicated brackets. In particular, we'll have values of a and b as larger values than they used to be. Alright, so before we look at any examples, I'm going to ask you to have a go at factorizing these brackets. What do they have in common with each other? Surely there is a common factor. So how would you factorize these brackets? Inside the bracket there's a common factor of x. So can we simply write x and then write 1 plus x raised to the power of minus 2? What's wrong with that? Well, what you factorized needs to also get a power of minus 2 as well. So it might be better to use a bracket, factorize inside the bracket, like so, and then distribute the power for each of these factors. So that's what we're going to get. Alright, have a go at the rest of them, pause the video, have a go, and then play the rest of the video. Alright, I hope you've had a go at these questions. The first one, as I said, it can be done in steps like so. Use the square bracket and factorize inside the square bracket and then distribute the power. The next one has a common factor of x cubed as both terms inside the bracket. Alright, and then distribute the power. 1/3 times the 3 gives the power of 1. Alright, are you getting the pattern? Next one, there's a common factor of a quarter and x the power of 4 actually. So you write it like so and then distribute the power. You'll get such an expression if you do it correctly. Alright, have a go at the next one and look at the answer. Alright, so the reason we did that is because our formula, if you look at it on top of the page, is always in terms of 1 plus x. So this expansion doesn't work if we don't have a 1 added to x here. So you can't have it as any other number bigger than 1. Therefore, we have to factorize this a such that you will get a value of 1 inside the bracket here. That means even though that there is no factor of a in the second term, when we factorize it, that means we have to divide the coefficient of x by a. So you end up with such expression like so, and then when you distribute the power of n for each of these brackets, each of these terms, you will get such an answer like so. So let's see how it works with an example. Square root can be written as power of a half, right? So let's write it with power of a half. This 4 needs to become a 1. Therefore, we need to divide every term inside the bracket by a factor of 4, and then make sure that the factorized 4 gets a power of a half as well. So what's 4 to the power of a half? 4 square root of 4 is 2 simply. So we'll have a factor of 2 outside the bracket. Notice that we don't have x any longer, we have x over 4. So we're going to use x over 4 in our expansion formula. Our value of n is going to be a half, and our x's need to be replaced with x over 4. In the general form of the binomial expansion, we'll have these terms here, and we're going to substitute half for n and x over 4 for x. So going through the motions and multiplying out the answers, you'll get so once you got to this stage, don't forget that there was the 2 outside our bracket. So we need to multiply every term here by a factor of the 2. Alright, so we also need to give a valid answer for which values of x this binomial expansion will be valid. Well, x over 4 has to be less than 1. So absolute value of x over 4 has to be less than 1. That means that actually now absolute value of x can be less than 4. Alright? Because, of course, if you look at these brackets, after all, we're dividing all these x's by 4. Okay? So let's look at another example. In this question, we've been asked to calculate 2 plus 3x raised to the power minus 2. Right. So actually, this was the question, and this is how we rewrite it. Okay, so let's look at the next question. In this example, we've been asked to find the first four terms of binomial expansion of 1 over 2 plus 3x raised to the power of 2. Let's rewrite that fraction with a negative power as a linear term. So if we rewrite that, we'll get 2 plus 3x raised to the power minus 2x, 2. So the first step in our calculation is make sure that we will have a 1 rather than a 2 here. So we need to factorize a 2 out of both these terms here. That means dividing 3 by 2 as well when you pull a, pull a 2 out of the bracket. Make sure you put the power of minus 2 on top of the factorized 2. So this term here can be written as such. So then we'll distribute the power of minus 2, and 2 to the power of minus 2 is a quarter. So let's leave that as a quarter outside the bracket. Let's deal with a bracket that has a power of minus 2 with the binomial expansion formula. So the general form is, and substituting n equal to negative 2 and x being 3 over 2 x, we get, right, going through the motions and putting those values in your formula, into your calculator, you'll end up with these terms here. Now is the time to multiply everything by quarter, because after all, our work needs initially had a quarter in front of it, our bracket. So we'll get this expression here. Finally, you need to say for which values of x the binomial expansion is valid. So looking at our terms here, this expansion 3 over 2x, its absolute value must be less than 1. So we write it like so. Absolute value of 3 over 2x is less than 1. Multiplying both sides by 2 over 3, we get absolute value of x must be less than 2 over 3. Okay, so I hope you found this helpful. I'll see you in the next video.